Hello friends, let us now learn some important points about the polychromatic radiation. So the attenuation of polychromatic radiation is more complex when compared to the monochromatic radiation. Polychromatic radiation beam contains a whole spectrum of photons with various energies, the most energetic of which are determined by the kilovoltage peak or peak kilovoltage used in to generate the beam. In general, the beam energy of the polychromatic radiation is between one third to half of its peak energy. So, if these are the different leads, different materials, thickness of different materials, and if 1000 photons and 40 kilovolt mean, if X-ray beam begins with 1000 photons and having a mean energy of 40 kilovoltage, after first centimeter of absorber reduces the photons by 35%. The photons will reduce by 35%, which is around 650 photons. Again, the photons are reduced by 27%, which is 474 photons. Later, the photons are reduced by 365 is reduced by 23%, resulting in 365 photons. So, if you see here, the percentage of reduction in photons is decreased as the thickness of the absorber is increased. The percentage of attenuation of photons is decreased as the thickness of the absorber is increased. This is because if you take an example, 1000 photons have a mean energy of 40 kilovolts, and when 1000 photons are attenuated, there will be 625 photons. 35% is attenuated. The remaining photons, there are 1000 photons, but here there are 65 photons, and if you see the mean energy of these 1000 photons is 40 kilovoltage. As the energy increases, as the transmission increases, the mean energy increases. So for this, we will see first, when a polychromatic radiation passes through the absorber, the transmitted photons undergo a change in both quality and quantity. That is, the number of photons decreases because some of the photons are absorbed and some of the photons are deflected, as they are with monochromatic radiation. Similar to the monochromatic radiation, when a polychromatic radiation passes through the absorber, the number of photons decreases because some of the photons are deflected and some are absorbed. Whereas, in contrast to monochromatic radiation, the quality of the beam changes because when the polychromatic radiation passes through the absorber, lower energy photons are more readily attenuated than the higher energy photons. As the lower energy photons is removed from the beam, so the intensity is decreased. So lower energy photons are attenuated more than the higher energy photons. As lower energy photons are removed from the beam, the mean energy will decrease. So for example, if 12 and 40 are the energy, so now lower energy photons are first attenuated by the absorber. So from 12 to 25 they are attenuated. Now if you see, the mean initial energy is 40 minus 12 by 2, which is around 38. Whereas mean energy of the final is 40 minus 25 by 2, which is the mean energy of the photon increases. See, generally this is not how you see, but generally if you see, this is the initial energy. If this is the initial energy, this is the mean energy. The calculation has gone a bit wrong. But anyways, if this is the final energy 40 kilo electron volts, this is initial energy. The mean energy will be somewhere in the middle. Okay, but when you see the mean energy between 25 and 40 kilo electron volts, the mean energy will be increased a little more, right? So as the absorber, the mean energy increases. On use of absorber, the number of photons decreases, the energy beam mean energy increases because lower energy photons are attenuated. So if you see here, kilo electron volts, 40 kilo electron volts, that is 1 centimeter of water. When 40 kilo electron volts X-ray photons are passed through 1 centimeter of water, the mean energy increases to 47 kilo electron volts. So again the mean energy is increased to 52 kilo electron volts after second centimeter of water. The third centimeter of water, mean energy is increased to 55 kilo electron volts. So if the mean energy increases, because of increase in mean energy, the percentage of attenuation decreases, because more the energy, lesser is the penetration of the X-ray beam. So the number of X-rays which are absorbed will, sorry, more the energy, more is the penetration. More is the energy of the beam, more is the penetration of the X-rays, lesser attenuation. So as a result, the attenuation of X-rays decreases as the as the radiation passes through the absorber. So that means when you draw a graph with percentage of transmitted photons against the centimeter of water or thickness of absorber on x-axis, you will see that you will require two curves, one for monochromatic radiation which shows linear attenuation, whereas polychromatic radiation initial slope will be steeper, because initial slope of the curve is steeper because many low energy photons are attenuated by the first few centimeters of water. Eventually the slope is similar to that of the initial curve is steeper because low energy photons are attenuated by initial first few centimeters of water. Eventually the slope of the curve becomes similar to the slope of the monochromatic curve or monochromatic beam as the mean energy of polychromatic radiation approaches its peak energy. So these are the important points about the polychromatic radiation. Thank you.